Welcome to the Entangled Show, a weekly conversation where we bridge the gap between high-level physics and everyday reality. I'm your co-host, Pete Codella, streaming from Utah's Salt Lake Valley.
And I am Sumit Parashur. I am from Bhilai and live in Lehigh. I live in two places at once, just like a quantum particle. I coined the term Quantonomy, which is what this show is all about. Thanks for joining us.
So Summit, we are talking about the fact that we live in a reality that is new and advancing quickly with lots of new technology, and we don't have the right words to describe our current reality.
Pete, you are so right on that. English as a language is still evolving. It has been around for such a long time. And the creators of our language, they did a great job of creating a foundation, but now it is upon us to create new words that take us to the next level, especially in the context of what we are going to discuss is that quantonomy or quantum related phenomena, that's something that our forefathers who invented words in English could have never seen coming. So we absolutely do need a new set of words or a completely new vocabulary to describe these phenomena.
And when we talked about creating Entangled Show, we were trying to come up with a platform to talk about quantum and how it applies. I think a lot of people are familiar with quantum computing, but quantum is a concept that expands beyond just computing. It applies to the economy, it applies to so many different things. And that's what we hope to discuss in the coming episodes of our show.
Absolutely. One other concept that I've been thinking about is in our show, we'll talk about everything pertaining to quantum, to quanta, and leading up to quantonomy. But in my opinion, this is the final frontier of science. When we have a good understanding of how things work at the particle level, we will have reached a point where we will have solved a lot of problems. So I completely agree.
Tell us what we mean by the term quantum.
Quantum is a word that portrays a singular object. And the context behind quantum is that we see light. Light comes, or understanding of the light comes very naturally to us. But our great scientists in the late 1800th century realized that light is not smooth, it is not continuous. It is built of units or it is built of pixels. So, from that perspective, a quantum is the unit or a pixel that, when put together in lots of units, creates the illusion of things like light. I'll take one more second on that. Is that an example of how we use quantum is photon, which is a particle that helps create light, is a singular particle that is referred to as a quantum particle. So photon is an example.
One of our goals with this podcast series is to bring the concept of quantum to the masses to help people understand. I keep thinking of the technology of artificial intelligence or AI. Right now, we are living in very fast advances in AI. And how does quantum fit in? Is quantum the next frontier in technological advancements? Does it come after AI? How does it replace or augment or support what we're experiencing with these AI technological advancements?
I and quantum, they are essentially the next steps that humanity is taking towards an nth level of evolution. Point,
Technological evolution.
yes, technological evolution. Going back to your point about bringing a quantum or quantum information or knowledge about quantum to the masses, that is our objective. Is that we want to demystify quantum terminology and bring it to a level where people like you and me can understand. There is definitely a psychological barrier that I've seen in people. When I mention quantum, people are kind of taken aback saying, hey, that's not for me, that's for scientists, and these terms are meant for people who work on the labs. We want to change that. We know that it is actually not that way. We, as human beings, all can understand quantum or quantum related technologies. And so, demystifying quantum terminology is definitely our key goal.
And one
Now,
of our
going
goals is to show how quantum is manifest in our current reality. So we'll bring some specific examples throughout our episodes of how quantum appears in our world.
Absolutely. Let me answer the second part of your question. How does AI and quantum coexist, or what's the future when it comes to AI and quantum? So, as we know, AI took us all by surprise. We've been working in AI way before Q4 of 2023, when ChatGPT was launched. We've been working on AI even before that, but that launch changed a whole lot. And all of us became aware that there is this thing called AI, and the masses can use AI to make themselves more efficient and the world a better place, essentially. So, same thing is around the corner when it comes to quantum technologies. Quantum technologies will be used to make AI even faster and even more efficient than it is right now. I drive a Mustang. An example of how I could make my Mustang even faster is that if I put a nitrous on my Mustang, it will go way faster and hopefully it can break the speed of light. Just kidding there. But that is something that we can expect even when there's a convergence. That is the word that is being used right now. When there's a convergence of AI and quantum, it will be like adding nitrous to a machine that's already too fast. So hopefully that explains the points and the question that you had.
So we've talked about quantum. Let's talk about quanta. Tell us what that means.
In all simplicity, if you see a photon and we call it a quantum object, quanta is multiple quantum objects.
So it's the
So
plural form of the singular.
in all simplicity, it's exactly like you said, plural of the singular quantum.
What about qualia? These are all new terms and we're just getting started, so let's define these.
When I figured out what qualia is, it literally blew my mind. Qualia is a definition of subjective experience of consciousness.
Something that we've discussed, not yet on the podcast, the ones and zeros in computer programming, and how quantum represents more than just a one or zero, a yes or no, an on or off. Is that kind of what you mean by qualia? It adds this additional layer, it makes it more dimensional.
Exactly. With qualia, we experience qualia on a day to day basis. For example, I am drinking coffee. Coffee is a little bit acidic, and a black coffee tastes a little bit bitter to me. That is qualia. Qualia defines a subjective experience or the properties of a subjective experience. And to your point, I cannot say on a scale of 0 to 10, saying it is 0 bitter or it is 10 bitter. It is somewhere in between. So there's not a 0 and there's not a 1. There is a lot of states in between that qualia represents. And exactly to your point is that it's not a on or a off. It is somewhere in between. Currently, my thinking is that if we look at any state or any experience that says no, it cannot be a 0 or a 1, then that kind of points back to the quantum nature of that discussion.
I'm going to pick up what you're laying down. I want to talk about drinks. I don't drink coffee, but I will drink a dirty soda. So let's say I've got my favorite Dr. Pepper and I add some coconut flavor to it, maybe some lime flavor to it. You talked about it can't just be, you can't rank it. I think the other element there is individual taste and senses, correct? Like, not only can maybe not give it a one or zero, but you multiply it then by every person who experiences that. And to each individual, that experience is just a little bit different.
That's deep, right? Now we are talking about experiences that can be shared in writing, in verbal, but thoughts and experiences that somebody or a body or a human body is experiencing cannot be shared in a lot of ways with the other individual. My belief is that, like I said, we are at a point in time where, as we study these quantum objects and correlate those to human behavior, human nature, we are actually getting to a point where this is the final frontier, where all the gray areas or the phenomena that we don't understand will begin to be explained by the subject that we have picked up.
Well, let's go back to our dictionary. You coined a term, quantonomy, and let's explain how that relates to all these other terms that we've talked about.
Yes, thank you for that. So I brought up a visual where it explains how we came up with the word quantonomy and what we are planning on using that word for going forward. I'm pretty interested in astronomy. I teach my kids about astronomy, and we look at planets and satellites and stars and galaxies and so on and so forth. And if you look at visual representations of quantum objects, they look pretty much the same. Following the lead from the English language, the grammatical rules of the English language, the study of celestial or astronomical objects is called astronomy.
Right. You've got astrology, you've got astronomy. And so we've applied that to quantum to get quantonomy.
Mhm. So, the study of astronomical objects is astronomy. The study of quantum objects is called quantonomy. Surprisingly, this word was not in existence before. My theory is that the godfathers of physics like Albert Einstein and Max Planck, they were so focused and busy in actually explaining the phenomena that they did not take a step back and they did not look at it from a perspective of lingua franca or the language that common people use. And they created this whole branch of science that is going to impact all our lives going forward. But I think it's our prerogative to go out and make that minor correction, take a step back, and start using an umbrella word like quantonomy that can explain objects at a quantum level and also the logic and the phenomena of how experiences and how consciousness works.
We've talked about perhaps several hundred episodes of the Entangled Show. And maybe one of our goals is to get quantonomy in the dictionary, have it be the word of the year. That'd be awesome.
I would love that. Based on all that I've seen so far, I have about 30 plus years of experience working in the industry. I did my electrical engineering 30 plus years back. Based on all that I've seen, this is something that is going to help humanity going forward. Simplifying or demystifying this particular science has been our objective. And yes, the day this word goes into Webster, we'll be honored.
Give us your elevator pitch for Entangled Show. Why are we spending our time talking about this? Why do we think it's the next frontier in technology? Why should people join us for this journey?
Again, Pete, I would love to summarize what we've talked about in the last few minutes. We are at a point in time where we are going to evolve exponentially in the next 5 years as human beings. Tough problems like maybe even intergalactic travel. I'm
Wow.
using big words here, but I see some dots where if those dots get connected by studying quantum objects, we could achieve intergalactic travel. We could find ways to improve human life and then also add to the human lifespan just on the basis of the topic that we have picked up. I mean, if you think of it that way, a photon is a particle that creates light, if you will. Also, it acts in mysterious ways because when we are not observing it, it is a wave. But when we look at it, it becomes a particle. So the day there is an explanation of why the collapse occurs. So, I don't want to go into that one particular word right now, but collapse is a topic in and by itself. The waveform collapses and it becomes a particle. But the day we figure out why that happens, that's going to open up doors. Now think of it this way, is that an electron and a photon that we see here are the same electrons and photons that could be seen. I'm not saying that they are being seen by people in the Andromeda galaxy, but they are pretty much the same. So, after the Big Bang, when hydrogen was born, hydrogen is all through or all over our universe, and an hydrogen atom here is the same hydrogen atom at the edge of the universe and maybe even beyond. So, we have all the raw material that we need to learn about the universe right here with us in terms of electron, protons, atoms, and so on. So what we are doing is going to elevate us to an nth level, and that's why I'm super excited. One other thing I'll throw out is that maybe we'll be instead of explaining how phenomena works or how quantonomy works, we'll be asking more questions than anybody on the planet right now can answer, and that will hopefully inspire a few kids or a few grown-ups to go deep diving and find the answers.
So, our next episodes, we're going to talk about the three pillars of quantonomy. Correct me if I'm wrong: superposition, probability, entanglement.
If I had three thumbs, I would have given you three thumbs up.
And that is where the Entangled Show name came from, is that pillar of quantonomy. So we'll discuss those. And then after that, we're going to invite some guests on, and we're going to start talking with them about quantum in the real world. Meanwhile, any of you who have questions about quantum, please send us a note at info@entangled.show. All right, Summit, any final words?
Now, this is beautiful, Pete. I am excited to be your co host on this journey. This is literally a journey that's going to take us to the nth level. So I'm super excited to start more questions that we can answer.
I feel like saying to infinity and beyond.
True, and very appropriate.
All right, we'll see you next time.
Okay, thank you, Pete.
The Entangled Show podcast is available on YouTube and wherever you get your podcasts. Please like and subscribe to the pod. Connect with us at entangled.show or send an email to info@entangled.show. I'm Pete Codella. Thanks for listening.
I am Sumit Parashur. Signing off for now. Thanks again for joining us here at the Entangled Show. We'll see you next time.